Yesterday we took a look at how to add and subtract when there was a common denominator. Now we're going to look at how to add and subtract when there's not a common denominator, but the denominators are factored. So the first thing is you're still going to find your common denominator. Okay, we went over yesterday how to find the common denominator. Remember that you represent each factor to the highest power. Okay. Then what you're going to do is you're going to fix the tops by multiplying by what was the missing factor from the common denominator to the original denominator. Okay. So remember, if we have something like 1/2 plus, let's do 2/6. Okay. Our common denominator is going to be 6. Okay, because 2 goes into 6 and 6 goes into 6. So I'm going to rewrite my common denominator. So to go from 2 to 6, my thing that I multiplied by is 3. So I have to multiply by 3 on the top. Here, to go from 6 to 6, we're just multiplying by 1. So I do 2 times 1, which is 2. And then we're going to add the tops and keep the common bottom. So then we get, equals 5, 6. Okay, so that's how we do fractions with just numbers. Now we're going to do that same thing, but it's going to have expressions in them. So we first need to find our least common denominator. So we represent the x minus 4. Is there any other x minus 4? Why, yes, this is an x minus 4. Both of them are to an unsaid first power. So I keep them as is, because between first power and first power, the highest is 1. So I'm going to leave a little space for the top here, and I'm going to write x minus 4. I have not represented the 2x squared plus 5. This cannot factor, because there's only 2 terms and there's not a minus, so it's not a difference of squares. So we just have to keep it like that. That doesn't match anything else, so I keep it as 2x squared plus 5. This, we have not represented the x plus 1, so I represent the x plus 1 with its current power, because there's no other one, so I leave it as is. Okay, so now we're going to play like this little matching game. All right, so if you just want to cover this up momentarily. Okay, if you look from here to here, what matches? Well, this matches and this matches. But I'm missing this. So I need to multiply this top by what was missing, so the x plus 1. So this is like playing the Sesame Street game, like which one of these things is not like the other, right? These are the same, these are the same. This thing is not like the other. So whatever the thing not like the other is, you have to multiply it by the top. So I'm going to multiply by x plus 1. Okay. I'm going to pause. I'm not going to do the actual multiplication, and now I'm going to cover up this side. And now we're going to play which one of those things is not like the other. Well, this is here, this is here, this is not. So I need the 2x squared plus 5 to be multiplied by the top. So I'm going to multiply the top by 2x squared plus 5. Okay. So now I'm going to multiply on top. So here to here, here to here. So this is 9x squared plus 9x. Remember, this is what we did the other day. This is multiplying polynomials. Then you have a plus in between, and then this will be 2x squared plus 10, right? So this is, I combined 2 steps in one. I found our common denominator, right? And then I'm doing the this plus the this on the top. I haven't combined like terms yet, okay? But I put the this plus the this on top. That would be like if I had written right here 3 plus 2 over 6. Okay. So now the 9x squared and the 2x squared are like terms, so we get 11x squared plus the 9x plus the 10. Keep the common bottom. Okay. You should double check that the top does not factor. It does not, so that is our answer. If it factors, you want to check for any common factors. Okay? So let's look at a subtracting problem. Okay? Remember, subtracting fractions, the only thing that you do different is, just like when you subtract polynomials, you have to make sure you distribute the negative. Okay? So we're going to find the least common denominator. So here's an x minus 3. Any other x minus 3? No. No, close, but not the same. And no. So I keep the x minus 3. I have an x plus 1. This is also an x plus 1, but they're both to the first power, so they match. So I represent x minus 1 to the first power. I have an x plus 3 that has not been represented, so I represent the x plus 3. So now we play the Sesame Street game. Which one of these things is not like the other? So, right, we've got the underlined and the squiggle, so this is missing out, right? So I guess I should double line that one. So I need to multiply the top by the double line, so x plus 3. Okay. Then the second one, so we're ignoring this one. Don't worry about your subtract sign yet. Okay. If I go from here to here, okay, the x plus 3 matches, the double lines, and the x minus 1 matches. So I'm missing the x minus 3, so I'm going to multiply the top by the x minus 3. Now, remember, when you're distributing, when you're subtracting, you need to distribute your negatives. So what I can do is I can change this to a plus and put my minus here so that when I distribute here, it distributes my negative and the 3x. So you kind of save yourself a step because you're kind of doing 2 in 1. So when I multiply this first one, I'm going to do 5x plus 15. And then here I'm going to do negative 3x times x is negative 3x squared. And then negative 3x times negative 3 is positive 9x. Okay? Again, I have not combined like terms. That's what we do next. Okay? You can write it in descending order, so the squared would be first, so negative 3x squared. You don't have to because addition is commutative, so as long as you keep the signs the same, you'll be fine. So 5x and 9x is 14x. And then we took care of the negative 3x squared, and we just have the plus 15. All over, keep the common bottom. Okay, we are all done. Okay. This last one has 3, so it's just a longer version of what we've just done. Okay, so I check this first one. Is there any other x minus 2s? Yeah, there's this one and there's this one. This has a 2, this has an unsaid first power, this has a 2. So between 2, 1, and 2, what's the highest power? 2. So we're going to write the x minus 2 to the second power. I have to represent the x minus 3. Is there any other x minus 3? Why, yes, there is. This x minus 3. This is to the first power. This is to the first power. So I'm going to represent with the highest power, but between 1 and 1, 1 is the highest power, so I keep x minus 3. So now we play which one of these things is not like the other. So use this to cover up again. From here to here, which one of these things is not like the other? Well, I'm totally missing the x minus 3, so I need to multiply this top by x minus 3. Okay. If we look at the middle one, we have the x minus 3 and we have the x minus 2, but there's something different about the x minus 2's. Can you spot it? This one is to the first, this one is to the second. So in order to make a match, if I want this to be the second, I would have to multiply by another x minus 2. So I have to multiply the top by an x minus 2. Okay? Because, let me say that again, this was the first power, this one's squared. So if I want this to turn into squared, I'd have to multiply by an x minus 2. So since we're missing a set of x minus 2's, I have to multiply the top by x minus 2. Okay? Then our last one, if we compare, these match and these match. So am I missing anything? No, I am not. So when you're not missing anything, you're just going to times by 1. Okay? So now what I'm going to do is we're going to multiply on the tops. Okay? So we're going to do 4 times x is 4x. And then 4 times negative 3 is negative 12. This is a plus sign, so I don't need to worry about distributing the negative. So I'm going to do plus 3x, and then 3 times negative 2 is minus 6. This is a negative. So since I'm multiplying by a 1 over here, I'm going to change this to a positive and multiply my negative with the 1. So I'm going to do negative 1 times x squared is negative x squared. Negative 1 times x is negative x. And negative 1 times negative 3 is positive 3. Okay? So now I'm just going to combine like terms because we did top plus top minus the top, right? And we distributed our negative properly all over the common bottom. Okay? So now if we look here, the x squared, that's all by itself, negative x squared rather. So we have negative x squared. We have, oh, whoops, that's the same thing. We'll just do a fat line. 4x and negative x, as well as 3x. So 4 plus 3 is 7. 7 minus 1 is 6. I did not miss any others, so plus 6x. And then we've got negative 12 and positive 3 and negative 6. So now we've got everything. So negative 12 minus 6 is negative 18. Negative 18 plus 3 is negative 15. All over, keep the common bottom. So x minus 2 squared times x minus 3. Okay. Remember, you ought to check to see if you can factor, so I would do negative 1 times negative 15. So I want to see, can I multiply to 15 and add to 6? So we would think 1 and 15, 2 doesn't go into it, 3 and 5, 4 doesn't go into it, and then 5 goes into it. These are all, can either of these add to 6? No, they cannot, so I cannot factor at the top. So I leave it like that. And that's how you add and subtract without common denominators, but they are factored.